This is the lesson for 7.5 on the distance formula. As always, we'll start with our learning objective. I can use the distance formula to find distances between points. So when we have a graph and the lines go straight up and down like this, or straight left and right like this, it's pretty easy to get the distances of them. We just count it. It's not a big deal. But when we have lines that slant on a graph, it's a little bit harder, and we use what we call the distance formula. So the distance formula actually comes straight from the Pythagorean theorem. So I want to talk to you guys about how that happens and what's going on with these. So we're going to use this picture of a triangle to kind of help us look at this situation. So the first thing I'm going to do is I'm going to label my sides A, B, and C. So remember, if our right angle is here, C should always be across from it, and A and B can be in either order. Now the next thing I'm going to do is introduce some points. So this is the point 1, 1. This is the point 4, 1. And this is the point 1, 5. So I want you guys to notice something really specific when I'm doing this, is that this one ends up here, and this one ends up here. You see how those match up? So that's really important. That's a key feature that you need to know. So we're going to talk a little bit about some things you probably haven't seen notation-wise before. And that's why I gave you the numbers first. But you also need to realize that you could call this point x1, y1. Remember, we've talked about how the number down below like that is just like kind of naming. It's just telling you which point is which kind of thing. Okay, and that's true. Now with 4, 1, what I want you to realize is that 4, 1 is actually, so it's at a different x value, or we'll call that x2, but it's actually at the same y value, so we're going to call it y1 again. And this one, same thing, it's at the same x value, so we're going to keep that, but it's at a different y value, so we'll call that y2. Okay, so the reason that works is because these have the same x. They both have the 1 as their x value. And these two, it works because they have the same y value. They both have that second one. Okay. So that's just some notation that we're going to use in this formula. So I just wanted to make sure that you kind of knew what it meant. So we're going to go ahead and dive in to how we actually use all of this information to get the distance formula from the Pythagorean theorem. So the first thing I'm going to do is I'm going to talk about the length of A. Okay. The side length A is this one right here. And we could pretty easily just count it, right? It's 1, 2, 3, 4 long. And that's true. But let's say we didn't actually know what points these were sitting on. You can actually find the length of A by doing y2 minus y1. So for this triangle specifically, you would do 5 minus 1 to get your 4, which is 1, 2, 3, 4, exactly what we think it should be. Okay, but again, let's pretend we don't actually have a specific triangle we're talking about. We're just talking about a general one. This is still going to hold true. You can do the same thing for B. Okay, so B, but this time it's the y value is not changing at all. It's staying constant. So the way we would do this is we would take this x value and subtract this x value to get this length. So what we say here is that you would do x2 minus x1. So in this one, x2 is 4 and x1 is 1. So we're thinking it should be 3. So let's count it. 1, 2, 3. Sure enough, this works. Okay. So then you can use substitution. Okay. So let's go ahead and put that in. So we know that A, and I'm going to actually change the colors up here so that it's a little bit more clear which one's which. Yeah, let's make that one orange. And we'll make this one, let's make this one blue. Okay. So when we have A squared, instead of A, I'm going to write y2 minus y1, but that is still squared, plus, and instead of b, I'm going to write x2 minus x1, and that's still squared, and it still equals c squared, which is what we're actually trying to get, right, is c. Okay, so now, to get c alone, this is actually in a pretty good place to get c alone. All we have to do to get c alone is square root it to get rid of that square, right? So remember, these will cancel each other out. Be careful with that though, because these two and this do not cancel each other out. This plus sign makes it so that this has to stay there. So on this right side we have c, and I'm actually going to switch that to the left side. Okay. And then what we end up with is c equals y2 minus y1 squared plus x2 minus x1 also squared. And if you'll notice, mine are backwards. I should have flipped them. I'm sorry. So you can flip these around, okay? Addition doesn't matter what order you do it in, right? You can do 2 plus 3 or 3 plus 2, and you're going to get the same answer. Okay. So, well, yeah, we'll go ahead and flip it. So we ended up with x2 minus x1 squared plus y2 minus y1 squared. Okay, so now we're looking a whole lot like this one. Okay, and I do realize that I flipped these numbers, but remember we gave those the names, right? I gave those names. So all that's happened here is that when whoever did this formula did it, they actually called this x1 and y2, and this one x2, y2, and then this one x2, y1. Okay, so that's all that happened, is that when I named things, I did it a touch differently than they did. Okay, but these are equivalent. Okay, so that's all great. That's how we figure it out, but you need to know how to actually use it. So we're going to go ahead and practice. So on this one, the first thing you're always going to do is write out your coordinates. So this coordinate is at -2, 0. This coordinate is at 1, 2, 3, 4, 5, -1. Okay, so then all we have to do is plug in what we know. So step one, always, always, always write out the formula. So distance, or c, equals the square root. Okay, and you can do this x's first or y's first, it doesn't matter, but you need to be consistent. So if you say that this is going to be x1, y1, then this one has to be x2, y2. Okay, so then we would do, okay, let's start with our x's just because that's what the formula actually says. Okay, and the formula, if you look at it, says to do x1 first. Doesn't actually matter because we picked which one's which, but that's fine. So we're going to do 5 minus a -2 squared plus, then we're going to do the y's. So if we started with 5, we need to start with -1 on this one. So -1 minus 0 squared. Okay. So then we got to simplify. Now you can put this whole thing in your calculator just like that, but I think it gets a little bit confusing. I think it's easier if you simplify first. So 5 minus a -2. Remember, when you do minus a negative, it turns into a plus. So this is actually 7 squared plus -1 minus 0 is just -1 squared. Okay, I think that step makes it easier to put in your calculator. It's obviously up to you. You could put it in there straight from the first one, and that would be fine. Okay, and then I'm going to switch to my camera here so you guys can see my, let's see here. Okay, so with our calculator, Now we wanted to do the square roots. Remember, you do second, this blue button, and then the square root button. And we wanted to do 7 squared. So remember, we do parenthesis. Oops, sorry, wrong button. Parenthesis 7 parenthesis squared plus parenthesis -1 parenthesis squared, and then you end the whole parenthesis for the square root part, and you hit enter. And you get a big old decimal. Okay, so there are 2 options here. If I ask you for an exact answer, then you're going to have to actually do 7 squared, 7 squared plus a -1 squared, and that comes out as 50. Okay, so what that means for our notes is that there's 2 possible answers here. If I ask you for an exact answer, you would say D equals the square root of 50. If I ask you for an approximate, you could say D equals 7 point, let's round to 1 decimal point 1, so because it was 7.07, so we'll say 7.1. So these are kind of the 2 possible answers I could be looking for. This one is exact. This one is rounded. Okay, so what we're saying is the distance from here to here is the square root of 50, or about 7.1. Okay, so let's do another example together. Okay, let's go ahead and write down our points first. So this is at -1, -2. This one is at 1, 2. And we're going to call this one x1, y1. And this one y1, or sorry, x2, x2, y2. And we're going to write out the formula. Distance equals the square root. Let's do our x's first. Again, let's actually do our y's first this time, just to show you that it really doesn't matter. So with our y's, I'm going to start with y2. So I'm going to do 2 minus a -2 squared plus, again, we started with this 2, so we have to start with this 1. 1 minus a -1 squared. Now again, you can put this straight into your calculator. I think it gets kind of hard with the parentheses, so I would simplify first. And I would realize that 2 minus a -2 is actually 2 plus 2. So this is going to be 4 squared plus, again, 1 minus a -1 is actually a plus. So 1 plus 1 is 2. Okay. And you can go a step further. You could also put this in your calculator at this point. I'm just going to go to there because I know what those are. So that means the answer is the square root of 20. Now on your calculator, you can just right here go with square root of 20 because I already know it's going to be that, and I can already get a decimal point, and that's fine. Okay, so 4.5. So I just wanted to show you that you can actually do the rounding at the very end. Okay, and again, these are going to be your 2 possible answers if I ask you for an exact answer or a rounded answer. Okay. All right, so I really want you to try these 2 on your own. So go ahead and try them, pause the video, and come back when you're ready for the answers. Okay, so again, we're going to label our points first. So this one is at 0, -2, and I'm going to call it x1, y1. And this one is at -2, -4. We're going to call it x2, y2. So we write out our formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We replace what we know. So this one would be -2 minus 0 plus -4 minus a -2 squared. Okay, and again, you can put it straight into your calculator from there. I'm not gonna. I'm gonna simplify a little bit. So negative 2 minus 0, that's just negative 2 squared, plus, and remember this turns into a plus, so negative 4 plus 2 is actually negative 2 squared. So that one's gonna be 4 plus 4, which is the square root of 8. Okay. Now again, you can go straight to your calculator, okay, and you can do square root of 8 and get an answer. It's going to be 2.8. Okay. And again, these are kind of the two answers you might need to give, either exact or rounded. Okay. So I'm going to do one more practice of this, just showing you how to enter this one exactly like that into the calculator. So you could do, okay, so if we wanted to start just from the top, what we would do is we would do the square root, okay, and then you're going to need another set of parentheses, and we did negative 2 minus 0. We're going to close that set of parentheses and square it. Okay. And then we're going to have to do plus and then a new set of parentheses. And then we did negative 4 minus a negative 2. Close that set of parentheses and square it. And then we have to end the last set of parentheses also. We hit enter. Sure enough, that's the same answer. Okay. So that's a little bit of help for you if you were struggling with the calculator part. So this last one, I really want you to do it on your own. I will put the answer up on Canvas, but I'm not going to do it in the video. Okay. Well, I guess I'll give you the answer, but I won't show you the work. So if you want to just double check yourself, we can say that this one is also the square root of 8. Okay. And my question for you guys is why? Why were these two answers the same? Okay, so let's look at why that might be. So this one, we start here and go up here. So we went up 2 and right 2. And we got that that was the square root of 8. Now this one, we go down 2 and right 2. And we also get the square root of 8. So why would that be? So I just want you guys to see this really quick. So if we created a right triangle out of this one and a right triangle out of this one, we can actually transform this one to get to this one, which makes them congruent, which is why the hypotenuse sides are also congruent. So that's kind of a fun Easter egg for you that we have talked about. So today I learned the distance formula. Something I need to remember from today is ... And you guys, I want you to fill that out. Let me know if you have any questions.